So this is the opening launcher for DipTrace. When you install it, you'll get a DipTrace launcher. So when you launch it, I like that it separates schematic and PCB layout. So it shows the user, these are two separate things. It also separates out components and patterns. So before we get started, what is a schematic? Well, a schematic is a drawing of a circuit or any engineering diagram really, but typically it's used in conjunction with electronic circuits. And then a PCB layout is basically an image of how you want the copper on the PCB to actually be etched and how you want it to, you're basically turning the schematic into a physical layout that you can actually send off to a PCB manufacturer and get your boards made. Components are what the symbols that you put on a schematic, and patterns are the footprints that you put on a PCB layout. So I like how they separate out these four things. But today we're going to start in schematic capture, and we're going to start really basic. So if you click on schematic capture, it'll open up the schematic portion of the software. Now I've got the nonprofit light version. You can email them and get the light version for free. It basically gives you an extra 200 pins, which is kind of cool of them. So this is your basic layout window. You can zoom in and out by scrolling your mouse wheel. Now another oddity, you can right click to pan around, by the way. Another oddity of the PCB industry is that we're still sort of stuck in half metric, half imperial, which is really annoying. Anything that's a through hole part, which means that the pins of the part actually go through the PCB, they're measured in inches, and anything that's surface mount, so parts that are soldered directly to the surface of the PCB, they're measured in millimeters typically. And this gets, of course, really frustrating, but since we're going to be working with through-hole parts only, we don't need to worry about it. So you can set your grid to either 0.05 or 0.1 inch to start. So the very first thing you do is you make a board. Actually, sorry, I'm thinking of PCBs. The very first thing you do is you make a box. So keep everything nice and neat. Now you can change the size of this box later. I'm just going to make one about yay big. I know our circuit's going to be pretty tiny. So what we're making today, we're going to do two circuits if we have enough time, depending on how long this takes. We're going to make a simple, just a resistor and an LED, so you apply power to it and it lights up. And then we're going to use an integrated circuit to create a flashing LED. So we've got our box. Again, doesn't matter how big it is, we can change the size later if need be by dragging. So we're going to go over to our left-hand side here. And we are going to scroll, let me think, what was the part I ended up using? Well, first we'll place the LED. So we'll go to discrete, we'll scroll down till we find LED, click on that. So now we're placing an LED. As you can see, it sort of snaps to the grid. So press the space bar, which will rotate it until we're pointing downwards. And we'll put that over here on the right-hand side. That's automatically labeled it as D1, which means diode 1. Which is a light emitting diode. Next, we need a resistor. So we're going to place, they've got a whole bunch of different widths. As you can see over here, we've got the schematic part component, and then we've got the footprint down here. So this is what it's actually going to put on the PCB. So two holes plus a little image, a little box that's going to be printed on the circuit board so that you know that that's a resistor goes there. So we're going to do a resistor 500, which is, I believe, 0.5 inches. Put that somewhere up and to the left of the LED. All right. Now, we need to give this resistor a value. An LED, it doesn't really matter, but with a resistor, it has to have a certain value. So click on it so it's highlighted. And then over here, in the value, double click, and then type in 470. So that means 470 ohms. Now we want to display that so that we can see it on the schematic. So we go down to marking 2 and we change it from default to value. So now we can see it's R1 and it's 470 ohms. Now we need a source of power. So we could actually build a power circuit here on the PCB, but this is going to be used with a battery. And so we typically create a connector so that you can, solder in a little battery connector and then snap a 9-volt battery onto it, for example. So we're going to scroll down until we get to, which one is it again? Is it TB headers? I don't think it is. Oh, it is TB headers. Perfect. So we're going to scroll. I'm just going to make sure I find the right width. No, see, these are metric ones. Is it backplane? No. That's strange. Oh, headers. I'm just looking at it the whole time. Okay, so click on connectors headers. And we could just use this one, but I don't like the fact that it's got this board edge thing on the footprint. So I usually try and find another one. Don't worry about all these part numbers. Let's see, 2.54, there it is. All right, so scroll down until you see this, 5-146253. It's not too far from the top. So if you scroll down, you can also search for it, but we're going to scroll down, and then we're going to pick 5-146253-1. All right, now we're going to place it to the left-hand side here. So as you can see, this is just going to create 2 holes in the PCB right beside each other that we could solder wires into. Okay, so now in any circuit, you always need a ground reference, and that's going to be connected to the negative of the battery. So we're going to scroll back up over here, and we're going to go to net ports. Now these are symbols that you place on the schematic to represent things like voltages or ground or other things. We're just going to pick a normal ground, and we're going to place it down at the bottom here. All right, so now we've got basically our circuit. I'm just going to move this down so it's a bit more lined up, but nothing's connected together yet. So what we need to do is come up here to this button, which is place wire. We're going to click on that, and now we're actually going to connect all these parts together. So go ahead and click on any one of these pins and connect everything together. There's this weird little glitch in this program. If you try and connect directly, it puts this extra little kink in it that it doesn't need. So I always just click here first, and then click here, and then click here. Anytime you want to override what it does automatically, you just click on the spot you want, and it'll do that automatically. It's doing the same thing again here. That's because this is such a small circuit. Alright, and we're going to connect the negative. And there we go. So now everything's connected together. I'm going to move this over. Now, we can give these nets names. These are considered nets, which just means anything that's connected together in a schematic is called a net. So this net down here, we're going to right click on it. So you just hover over the connector or the wire. I'll give you guys a minute to finish laying things out. So we're going to right click on that, and we're going to click on net 1, and we're going to change the name of this net to ground, GND, hit enter. This will help us when we go to actually lay out the PCB. So just to recap, so we went to discrete, we placed a resistor, or we placed an LED first, we hit space to rotate it, then we placed a resistor, and we clicked on it, changed the value to 470, and we made it so that it displayed the value instead of the default, which is nothing. We placed a connector, which was in header connectors, and then we placed a net port, which is just a symbol, and we placed the ground, and then we connected them all together using place wire. So there's our circuit. So if you applied power right here, the electricity would flow through the resistor, through the LED, make it light up, and go to ground. So that's a pretty simple circuit. So what we're going to do now is we're going to save it. And I've already got it saved here in my DipTrace tutorial, so we don't need to, you can save it whatever you can call it whatever you want. I'm going to overwrite my current one. Alright, so now that it's saved, hopefully if you're having any trouble so far, let me know in the chat. I'll go to Classroom 101. So now that we've created the schematic, we want to turn this into a layout, a PCB layout. So what we do is we click on File, and we say Convert to PCB. What this is going to do is it's going to open up the other section of DipTrace, the layout, and it's going to import all these parts into it. And it's actually going to remember what we have connected together and how we want it all connected. So click on Convert to PCB. This takes a bit longer to... Alright, so it's going to ask you what you want to do for your rules. Just say use schematic rules, click OK. Again, for the graphics mode, this is the first time you've opened it. I typically use Windows GDI. It says slow mode, but for me it's actually a lot faster. And then I always go with the black theme. It is much more comfortable in your eyes. Alright, so now we've got a grid and we've got our 3 parts. So first thing we're going to do is we're going to click View, and we are going to display the origin. So that way we can sort of orient ourselves and see where we are. Alright, so as you can see, it's already placed our 3 parts for us, and you can see there's these lines connecting them. These are called rat lines, and these represent the connections that we've made in the schematic. These actually aren't connected together yet. It's just a reminder to you that, you know, these are the connections you want. So the first thing we're going to do, whereas we made a box in the schematic, we actually need to make a board outline. We need to tell the PCB manufacturer this is how big we actually want the physical board to be. So we need to choose something that's going to fit all our parts. First thing we're going to do is we're going to select all of our parts by dragging, and then we're just going to move them sort of down here. And then we're just going to sort of move them just a little bit closer together. Alright. Now, we're going to go up here, and we're going to click on Place Board Outline. This is this button right here. Now this is, I'm not sure what the word is. It's kind of like drawing a polygon in a graphics program. So click somewhere along the origin here, above the top of resistor 1. And it's going to start out as a line. Then come over here somewhere, click again, then go down, make sure it's a nice neat right angle, click there, click on the origin, and then once again come back up to the upper left and click. And there's our board outline. It's purple, so you can differentiate it from other lines, which is nice. So let's zoom in a little bit now. So now we've got our board outline, so we need to keep everything inside of that. So we click on our little mouse pointer again so that we can move things around. So the first thing we notice is that, this end of the resistor is actually going to the bottom and the top one is going over here. So those are crossing over each other, which you can't, there's ways around that in advanced PCB layout, but most of the time we don't want things crossing like that. So we're going to click on J1, and again we're going to push the space bar twice to rotate it around like that. Alright, that's a little bit better. Maybe I want my LED to point downwards. So again, I'm going to rotate it. Actually, once again, we've got a cross, but I'm actually going to leave that in to show you one of the ways we can get around that. So now we've got things about where we want them. I think that looks pretty good. So now we're going to place our wire. Now, or we're going to, what they call routing, we're going to route the traces on the PCB. So we're going to choose Route Manual. Now, the first thing we're going to do is, let me just make sure, yeah, so that looks all correct over here. We're going to connect the end of this resistor here. Now you can see when I hover over it, it turns red. That shows this is what you want connected together. So click on the resistor. Then the nice thing about the routing is that it'll take care of the angles for you. Now, that's a bit ugly. Typically what I do is I sort of come over like this so that we get a nice angle in it and then go straight down. And that's it routed. So now those two paths are connected together with a trace. The next thing we need to do is connect the other end of the resistor to the bottom of the LED. So what we're going to do is we're actually going to come over here like this. We're going to go down and around like that. And then last but not least, we need to connect the other half, which is ground, to the other half of the LED. So again, we're going to come over like this, and I think we'll go just like that. So as you can see, even though these two were crossed over each other, I just went around the component. Now, if you've got other things in the way, you might actually need to go to the other layer. So in this, we've only done one layer. This is all on the top layer of the PCB. This is what they call a single-sided layout. Now again, I just noticed our resistor isn't showing its value. So again, we're going to click on it. We're going to go to marking, and we're going to go to value. So now when you're laying out, when you're actually soldering in the parts, it's easier for you to see, okay, that's a 470 ohm resistor. Especially you might have, tens or even hundreds of resistors on a board. It's really nice if you remember to put the values on. It makes it a lot easier. All right, so now we've got our board all laid out. So now if we wanted to send it off to the manufacturer, because there's so many different CAD softwares, you can't just click File, Save, and then send them this file. So we're actually going to save this. So this is, I'm going to name it one lead circuit again. So we can't actually just send this file because there's too many different formats. Every CAD software has its own proprietary format. So the industry has standardized on a file format called Gerber, which is what PCB manufacturers expect you to have. So what we're going to do is we're going to click File, Export, and then we're going to choose Gerber. So we're going to click on Gerber. Now it wants to know what layers we want sent. Well, we know we need the board outline, so hold down Control. We also know that we need the top, which is the top copper layer, which is all these connections. And then all these little, the J1, R1, these boxes, this is on what's called the silk screen. So that's actually going to be printed onto the PCB using silk screening. So we also want the top silk. And we also need the top mask. So that's the solder mask. And we don't need anything from the bottom layer because we're not using the bottom layer. So that's all the layers that we need. Actually, I think they also require paste, if I'm remembering correctly. It depends on the PCB manufacturer you're sending it to. Typically, their website will have a list of exactly what they require. So now that we've selected all those, we're going to click on Export. And it's going to, see I'm in a different spot now, so we're going to go back into our DipTrace tutorial. It's going to say top silk, so we're going to say save. Oh, that's because we have the top silk. I forgot you can't do them all at once. So then we'll select mask, we'll go export, top mask, and we'll do top paste, export. If you click export all, it's just going to do everything, and we don't want that. So we'll go top, export, and board outline, export. All right, so now if we were to go to that folder, actually I think it's in my documents, DipTrace, there it is, projects, DipTrace tutorial. So what we would do is we would take these files and we would actually put them into a zip archive typically. And then we would send that off to the manufacturer. So pretty simple. All right, so now that we've done that, let's step things up a notch. So close out the PCB layout. And let's, since we've, make sure you've saved this, click on New. We're going to start a new schematic. So now we're going to build the flashing LED circuit. All right, so we're going to need a little bit more space. So again, I'm going to make my box. So I'm going to click on Place Shape, and then Rectangle. And I'm going to make it quite a bit bigger. All right, so now we're going to do things a bit more properly, the way you would actually do it professionally. So the first thing we're going to do is, again, we're going to put a header on the board. So we're going to go to headers, and we're going to place that same part, 5146253-1. So we're going to place that up in the upper left here. Now, most circuits run on 5 volts, 5 or 3.3 volts, but we're going to be connecting a 9-volt battery to this. So we need to turn that 9 volts into 5 volts, and we do this with something called a regulator. There's a whole bunch of standard regulators that will regulate to a specific voltage, and one of the more popular ones is the 5-volt regulator, and the part name is the 7805. So because as you can see, our library is quite huge. There's tons of manufacturers and different types of things. We don't actually know where it's located. So we're going to click on filter, and we're going to search area. We want to search the entire components group. And then for the parameter, we want to search for 7805. So we're going to click apply filter. Now this always goes into not responding mode for some reason. I guess because it's at 100% CPU usage, but don't worry, it's not crashing. It is actually just searching. So just let it finish. All right. So I know for a fact we're looking for an LM7805. So we're going to use, here it is, LM7805. So that's exactly what we're looking for. So click on that. And then we're going to place it somewhere about there. So now we can click on cancel filter, and that'll go back to the full component library. All right, so the chip that's actually going to flash the LED, it's a very classic chip. It's been around, I think it was designed in the 1970s. It's called a 555 timer. So again, we're going to search for that using the filter feature. So we want to search in the components group, and we're going to search for 555. Then we're going to click apply filter. And again, it's going to say not responding, but it's actually searching. Oh, maybe this time it isn't going to say not responding. That's good. Okay, we got a lot of results again. So we're going to scroll down. And once again, we're looking for an LM555. So here we are. LM555, we want the LM555CN. N is in Nancy, not M. So click on that and put it over here somewhere. All right, so that's our chip. So again, we're going to click cancel filter. All right, so from here, we're going to refer to our standard 555 asynchronous schematic. So I'm actually going to open up Google, and this is a lot of the time what you're going to do as a professional is you're going to look for reference circuits. So we're going to search for a 555 flasher circuit, and we're going to look at the first result that comes up. So here's a schematic image. Now, I could do this from memory, but I wanted to show you guys how this all works. So we've got, we've got 4 resistors, we've got 2 LEDs, we've got a capacitor, and we've got our battery. It says 3 volts, but the 555 timer can accept anywhere from 3 volts up to, I think, 12 volts, but we're going to be giving it 5 volts. All right, so now we're basically going to transfer this into our schematic. So we know that we're going to need 4 resistors. So the first thing we're going to do, we're going to come back to discrete like we did before. We're going to scroll down until we have resistor 500. And we're just going to click, we're just going to put 4 resistors on. It doesn't matter where they are at this point. We're going to go back. Okay, we need 2 LEDs. So we're going to scroll up and we're going to find LED. We're going to place 2 LEDs. And then we need a capacitor. So we're going to, staying in discrete, we're going to scroll up. We're going to choose the cap 200 RP. So again, cap 200 RP, and we're going to place that. All right, so now we've got all our components. So now we need to connect them all up to the 555 timer so that it works properly. So we're going to refer back. So we're going to start up at the top here. So we can see pins 4 and 8 are connected together, and they're also connected to the power source. So the first thing we're going to do is we're going to click again on place wire, and we're going to connect pins 4 and 8 together. Alright, so those are connected together. Now we can see that pin 4 and 8, they're actually connected to one of the resistors, which then connects to pin 7. Alright, so there's pin 7. The way that they've actually made this component for the schematic, I don't actually like the way they've laid out the pins. So maybe in a future lesson we'll actually go in and edit this and change the way this is all laid out. Because as you're about to see, it makes things really messy, unfortunately. So we're going to move our resistor 1. We're going to press space bar. Actually, I think we're going to put it up at the top here. Let me take a look at the schematic again. So that connects to, and that will connect over to pin 6. Okay, yeah. So what we're going to do is we're going to put the resistor sideways right about here. Actually, see, because that has to get all the way over to pin 6. I remember doing this exact same thing when I was trying to create the example layout. Alright, so we'll figure it out when we get there. So we're going to connect one end of it to power, which is this net. The other end is going to connect to pin 7. So what value is that resistor? Well, that's 220K, which means 220,000 ohms. So we're going to click on resistor 1. Remember to click on the mouse pointer first because we don't want to be in place wire mode. So we're going to click on default mode, click on the resistor, and then in the value, double click, we're going to put 220K, enter, and then down in marking, we're going to show the value again. Alright, so what's the next thing that's connected? Well, that pin 7 is connected to another resistor. So we're going to take another resistor, we're going to put it right about here, and as you can see, we're getting a little bit close to the top of our box. So I'm just going to drag this up, make it a little bit bigger so we've got a little more room. We can change this around later if needed. So one end is connected to pin 7, which is this trace. So we're going to go back into place wire mode. We're going to click on this net, and we're going to bring it over to resistor 2. Alright. So now the other end of that resistor is connected to pin 6. So from pin 6, we're going to click like this and connect it to the other end. So that's got a value of 22K. So again, switch to default mode, click on the resistor, and then the value box, we're going to put 22K, and then we're going to change the marking to value. Alright, so what's the next thing we need to do? Well, pin 6 and pin 2 are connected together, and they're connected to that 10 microfarad capacitor. So we're going to connect pins 2 to pin 6. So we went into place wire mode and we connected pin 2 to the net that's pin 6. Then we're going to go back to default mode. We're going to grab this capacitor. We're going to move it over here. And we're going to press space bar to rotate it. And we're going to connect the positive side of it to pin 2 like that. Alright, and again, we're going to switch to default mode. It said that this was a 10 microfarad. So we're going to click on the capacitor, we're going to go to the value, and we're going to put 10 little u, so lowercase u, capital F. So 10 microfarads, and then we're going to change the marking to value. Oh, marking 2 has got to go to value. So I'm just going to mute TeamSpeak. So the next thing we need to do, on the other side, we can see we've got a 68 ohm resistor going into an LED, which is then connected to pin 3. Okay, so coming from the power rail, we need to move one of our resistors. So we're going to actually widen out the box again. We're going to take resistor 3, we're going to hit the space bar, we're going to put it up here somewhere. So this is 68 ohms, so we're going to click on it. We're going to go to value, and we're going to type in 68, hit enter, and again change marking 2 to value. Then we're going to grab one of our LEDs, we're going to press space bar so that it's pointing downwards. Oh great, it's somehow gotten off grid. There we go. Actually, we're going to move these up just a touch so that they line up with pin 3 a little bit better. Okay, so now we're going to connect this all together. So we're going to go back to place wire mode. We're going to click on the top of R3. Now again, it's going to try, oh yeah, see, it's going to try and auto route it like that. So the first thing we do is we just click one grid to the left, and then it'll automatically do a straight line for us. Then we're going to connect those two together, and then we're going to connect the bottom of the LED. Oh, see, it's doing this auto route thing again, so we just click one dot away, and there we go. Awesome. So now that this is basically replicated going down to ground. So we are going to go back to schematic, and we're going to take our other resistor and our other LED, and we're actually going to make it go sideways like this. Get it back on grid. There we go. Now you notice that when you rotate it, it might end up off grid. See how it's not lined up with the grid anymore? All you have to do is just pick it up and move it, and it'll snap back to the grid. So we're going to get it facing to the right, let go, pick it up again, and now it's on the grid. So we're going to move it down here. And once again, we're going to give R4 a value of 68. Going to change the marking to value. And now we're going to connect everything together. So we're going to connect the resistor to pin 3. I'm going to connect the other end of the resistor to diode 2. And we know that the bottom half of the capacitor is connected to ground, so we're just going to connect it to the diode. And there we go. We've got our 555 flasher circuit. So these two diodes will flash alternately. So now we need to deal with the power. So we're going to move that a little bit. First thing we need to do is we need to place some net ports like before. So we know that plus 5 volts is what comes out of this regulator. So near the out, we're going to place a plus 5 volt. And then we know that it needs to be connected over here to pin 8. So we're going to squeeze in a plus 5 volt right there. Now we're going to scroll down, and we're going to choose a ground. We're going to put one near the ground on this regulator, which seems to be off grid, which is interesting. So we'll actually go to 0.05 inches. There, now it's on grid. Move that over like that. And we're going to place another ground right here. And we're going to place a third one near the ground pin of that chip. Actually, we'll move that down just a bit. Alright, so now we're going to connect everything together. So first thing we're going to do is deal with the regulator. So we're going to connect the ground pin to ground. We're going to connect pin 1 to pin 1 of the jumper, or of our connector over here. We're going to connect pin 2 of the jumper to ground as well. Now we're going to connect the output to plus 5 volts. Alright, now over here we're going to connect plus 5 volts to this net 0. And we're going to right click on this net, and we're going to call it plus 5V. So now you can see that those are all connected together. And we're going to right click on this one, and we're going to call it GND. And now we're going to connect our last two grounds together. Like that, and like that. And there we go. We've got our flasher circuit all set up. So now to make things a bit more neat, let's drag and select the whole regulator circuit. We're going to move it down a little bit. And now let's drag and select the whole 555 flasher circuit. We're going to move it down as well. All right, that's not bad. So now we're going to shrink our box back down. Very good. Awesome. Now we're going to save as lead flasher. Yes, I want to replace it. And now we're going to lay out the PCB. So that wasn't too hard. So let's now do the same thing we did before. Click Convert to PCB. The PCB layout software always takes a bit longer to open. So again, use schematic rules. All right, so now you can see we've got a lot more parts and a lot more rat lines. So again, this time because the circuit's a bit more complicated, I think we're going to accidentally tugged on my Ethernet cable. All right, so hopefully the stream's back up now. So we're actually going to click and we're going to highlight everything except for J1. And then we're going to go to marking 2 and we're going to choose value. So that'll put the values for everything. Alright, so the first thing we're going to do is we're going to take our 555 timer chip and we're going to put it down over here near the origin. So we're going to try and make this circuit as compact as possible. Alright, so now we're going to move R1. We can see that it's connected to pins 7 and 8. So the interesting thing about a chip, the pin numbers aren't shown here, but this square one is pin 1. And the way pins are numbered on a chip, it goes pin 1, 2, 3, 4, 5, 6, 7, 8. So sort of in a U shape. Alright, so we're going to move R1 so it's, close to the chip, we'll say. Actually, yeah, we'll put it above it, sort of like that. We can always change our minds later. R2 we'll put above R1 like that. R3, we're going to hit spacebar, and we're going to put it up like this. Maybe it should go on the other side. Let me think about this for a minute. How is that connected again? Oh, right. It just needs to be connected to power on one side. So yeah, what we're going to do is we're actually going to put R3 on the other side, like that. And we're going to put R4 on the other side. Hit spacebar. Let's see. Hit spacebar twice. Okay. And then our capacitor, we are going to, let's see, we'll put it down here. So hit spacebar until we've got the plus side on the left. And then our two LEDs, we will put over here. So make sure they're both facing the same way. Okay. And then our connector and our regulator, we will put like this. I think we should flip this around. Yep. So hit spacebar twice to get that facing the right way. Alright, that's pretty nice and neat. Alright, so now we've got to start routing. This is going to be a bit more complicated because we're probably going to end up using both the top and the bottom layers for this one. So we're going to start on the top. We're going to start route manual. So we're going to start off simple. We're just going to route J1 to U1 like that. Okay. We're actually not going to route any of the grounds, and you'll see why later on. Alright, so now the plus 5 volts, we're going to route that. Let's see. Yeah, let's route it. Let me take a look at the rat lines again. Okay, we're going to, you know what, let's get the resistors and everything done first. So that way we'll know if we have to route our power around or if we can go through the middle. So we'll start off with some of the easy ones. We'll connect this over like this to pin 3. We'll connect the other end of that resistor around the capacitor up to the bottom of the diode. The other end of that will be connected to ground, so we're not going to route it. Then that LED is connected to this resistor. So we're going to do something clever here. We're actually going to go this way. We're going to go underneath that resistor and around like that. Okay. So that resistor is connected. Actually, let's go across like this and then down. And it's also connected, that's right, pins 4 and 8 are connected together. But we won't worry about that yet. Alright. So these 4 are all connected together. So we're going to bring that one over like that. Then we're going to connect that resistor down to that one. And connect it to pin 7. Alright, so we're almost done. So now you can see we're starting to run out of room. We might be able to squeeze this one through. Let's see if we can get this around. Let me see. Can I think of a clever way? Yes, I can. Alright, so we're going to come out over here. And we're going to go up and around to that resistor. And then we're going to go from there down to this pin. Okay. Now we're starting to get some that are pretty far apart. So what we're going to do now, actually, let's see. Yeah, we're going to connect pin 2 to pin 6. Now we're going to switch to the bottom layer. So we're going to click top and we're going to switch to bottom. You can see everything sort of fades out. So now we're going to get our last few connections done. So we don't need to route any of the grounds. So I'm actually going to right click on one of the grounds, like this capacitor, and we're going to say hide net rat lines. That means don't show us any of the ground ones because we don't need to worry about them at this point. Then we're going to go back to route manual. Remember that right clicking will allow you to pan. Alright, so our plus 5 volts we're going to bring down and across like this. And we're going to bring another one down to that pin. So now those are connected together. So you can see the way they're connected together is that pin is connected to this resistor, which then comes up through the hole and to the other one. Then last but not least, we're going to connect this diode all the way. Actually, you know what? Hit escape. I think we're actually going to go through one of the pins here. This is a clever trick that we use quite a bit. So we're actually going to go between the pins of that IC and connect it like that. So there we go. We've got it all routed. We've got everything except for ground routed. So now what we're going to do is we're going to switch back to the top layer and we're going to place our board outline like we did before. So just sort of, pick a rectangular shape that's going to fit everything in. Let's see, one more. We'll go down and across and back up. Alright, so now we've got our board outline. So remember how I said not to place any grounds? That's because we're going to do something called a ground pour. So we're going to switch back to layer 2, bottom. And then we're going to click on this button here, which is called Place Copper Pour. What this is going to do is it's going to flood fill, kind of like the paint can in Paint. It's going to flood fill the entire layer with copper, and then we're going to connect that to ground. And then it'll automatically connect all our grounds together for us. So click on Copper Pour, and then trace your board outline exactly the way you have it. So from there to there, to there, to the bottom corner, and then back up to the top left. All right. So now it wants to know what do we want it connected to. So we're going to click on Connectivity. We're going to connect to Net Ground. And that's basically all we need to do. We're going to click OK. And look, it's flood filled everything. And it's now connected all our grounds together. So actually, you know what we're going to do? We're going to go to the mouse pointer, and we're going to right click on the edge of the copper pour, and we're going to go to Properties. And let's see, we're going to go to Connectivity. That's interesting. I was thinking that it... Actually, we'll just cancel. It doesn't actually matter. Usually what it does is it does little spokes instead of, as you can see, what it's done is it's actually just connected directly to it all the way around. Usually it'll do 4 little spokes, which I think looks a bit neater, but this actually has better performance. All right, so now we're going to go to our top layer. So you can see the bottom layer is now flood filled. And that's it. That's our board. So if you guys actually want to get this board made, which I highly suggest you do, you can contact me and I can walk you through the process. It's pretty cheap. You can make some changes if you want. If you want help with that, let me know. So again, you're going to do the same thing. File, Export to Gerber. But this time, we need the top silk, mask, paste, top, bottom, paste, mask, silk, and board outline. This time we're going to try Export All, and we'll see if that works. All right, actually, what we'll do is we'll click Export All, and then we'll just cancel the ones that we don't need. So we're going to make a new folder, and it's going to be called Lead Flasher. We're going to go into that folder, and so now we don't need the top assembly, so cancel. We do need the top silk, so we'll go into Lead Flasher. We do need the top mask. We do need the top paste. We need the top. We need the bottom. We need the paste. We need the mask. We need the silk. We don't need the assembly. We do need the board outline. We don't need the dimensions. And, oh, I accidentally saved the bottom dimension, but you should click cancel there. And now we're done. So again, you can go to that folder, zip them up, and send them off. If you're interested in actually getting this board made and soldering in all the components, I would be more than happy to help you. But that's basically our lesson. If you've been watching along and you have any questions, just join our kernelization server. You can contact me through Twitch or through YouTube and send me a message, and I'll get you set up with our kernelization Discord server, and you can ask me questions and I can help you out if you need help. So thanks so much for watching, and I hope that you will come for lesson 2, which will probably be in about a week or so.